This session is about a new line drawing algorithm called Bresenham's line drawing algorithm. This algorithm is an accurate and efficient line drawing algorithm, and it was developed by Bresenham. And this algorithm will convert lines only using integer calculations. To find the next x and y coordinate position which is to be plotted, it uses only integer calculations, whereas in the previous DDA line drawing algorithm used floating point arithmetic, which was time consuming. So this also avoids incremental error accumulation. Okay, fine. So when you have a pixel position along the line path, say for example, you have a point xk and yk, then we must decide which point will be my next coordinate. So we will always have x coordinate incremented by 1, assume. So always xk plus 1 and xk plus 1, whereas the y coordinate alone, we need to make some decisions whether to choose yk or yk plus 1. So this decision has to be made. So for making this decision, let us assume we have a graph like this, and this particular point is xk, and this particular this is yk, and this is xk, and this y is equal to mx plus b, which is the Cartesian line equation. So for the next coordinate xk plus 1, I have to choose either this point or this point, that is yk or yk plus 1. I don't know which one to select. So let me keep a point here in the middle, okay, between these two. And the distance between this y minus yk is d1, and the distance between yk plus 1 minus y is d2. So given in the next equation. So d1 is represented as the distance between y minus yk, and d2 is represented as yk plus 1 minus y. And we are dealing with the point xk plus 1. So we know the Cartesian line equation is y is equal to m into xk plus b. Since we are considering xk plus 1, I am applying y is equal to m into xk plus 1 plus b. So substituting the value of y in these two equations, we got this expression, this m into xk plus 1 plus b minus yk, and yk plus 1 minus m into xk plus 1 minus b. So substituting this values here. So next step, I need to find the difference between this d1 and d2. When I find the difference between d1 and d2, it will be resolved, and the final equation formulated will be like this. Now I have to make a decision parameter or define a decision parameter with the help of the above difference. So the decision parameter is given by pk is equal to del x into the difference that I calculated, that is d1 minus d2. Okay, so this del x can also be written as using the formula m is equal to del y by del x. I can calculate the value of del x and substitute here. So when I substitute those values, the equation which I get is 2 del y into xk minus 2 del x into yk plus c. So all these derivations are not that much essential. So finally, the decision parameter depends upon the value of the difference between d1 and d2. If d1 minus d2 is going to be, if d1 is lesser than d2, then it will lead to negative value for pk, that is less than 0. If d1 is less than d2, then pk will be less than 0. And if that is the case, my points to be plotted will be xk plus 1 comma yk. Else, that is, if pk is equal to 0 or greater than 0, my next point to be plotted will be xk plus 1 comma yk plus 1. So now I can make a decision whether to choose xk will always remain xk plus 1. That was going to be x will be going to be incremented by 1 always. So x is nothing but xk plus 1 every time. But whether to choose yk or yk plus 1. So that decision is made with the value of d1 and d2. If d1 is less than d2, then it leads to pk less than 0. In that case, the first pixel will be plotted. Otherwise, the second pixel will be plotted. So every time after plotting the pixel, we need to calculate the decision parameter for the next step. So the initial decision parameter is given as P naught. Every time after finding the new value of the pixel, that is xk plus 1 comma yk or xk plus 1 comma yk plus 1, we need to find the new decision parameter as well, that is pk plus 1. So pk plus 1 is given by the formula previous pk value plus 2 del y minus 2 del x into yk plus 1 minus yk. This yk can have two values. It can have either 0 or it can be either 1. It can be 0 or 1. So if it is going to be 0, this entire component will be lost. So pk plus 1 will be pk plus 2y. So that happens when pk is negative. If this is 1, then pk plus 1 will be pk plus 2 del y minus 2 del x. So based on this difference, if it is 0 or 1, we can formulate new formula for pk plus 1. So with this derivation, we will next move on to the algorithm. So the first step in the algorithm is we have to input two endpoints. That is, with the help of two endpoints only, we can draw a line. So we will have two endpoints. The second step is to plot the first point. So this is my second step. The third step is to calculate the different values, that is del x, del y2, del x, which are all required as per the formula. So these calculations are done in the third step. In the fourth step, we need to find out which is the next point to be plotted, whether it is xk plus 1 comma yk or xk plus 1 comma yk plus 1, which depends upon the value of pk. If pk is less than 0, then this is the point to be plotted and this is the next decision parameter. If pk is greater than 0 or if it is equal to 0, then this will be the point to be plotted and this will be the value of the next decision parameter. The above step 4 is repeated del x times. So with this algorithmic steps, we will solve two examples to get better idea of Bresenham's line drawing algorithm. So here is the example. Calculate the points between the starting coordinates, that is 20, 10 and the ending coordinate 30, 18. So there is an important point to be noted. Always this Bresenham's algorithm is used when the slope is less than or equal to 1. So remember, always when slope is less than or equal to 1, only then your Bresenham's algorithm can be used. So first, you have the given point, that is starting point x naught y naught as 20, 10, x and yn as 30, 18. We will find out del x and del y. We know del x is xn minus x naught, that is 30 minus 20, which is 10, and del y is yn minus y naught, which is 18 minus 10, which is 8. The slope here is del y by del x, which is 8 by 10, which is 0.8. So 0.8 is less than or equal to 1. Therefore, I can apply Bresenham's algorithm to this problem. So before going for the calculation, I need to find out the initial decision parameter P naught. So the initial decision parameter P naught has a formula 2 del y minus del x. In our case, del y is 8, del x is 10. So 2 into 8 minus 10, which is 16 minus 10, 6. So the initial decision parameter P naught is 6. Now, we know If pk is less than 0, this is the point, this is the decision parameter, case 1. If pk is equal to 0 or greater than 0, this is the point and this is the decision parameter. In our case, pk is 6, which is greater than 0. Yes, pk is 6, which is greater than 0. So case 2, this part is satisfied. So we will compute new pk plus 1. The new pk plus 1 is given by the formula pk plus 2 del x minus 2 del y, which is 2. And the next point will be x will be incremented by 1, y will be incremented by 1. In our case, initial point x was 20 and y was 10. So that is why 20 plus 1 and 10 plus 1. So the next intermediate point to be fixed or plotted is 21, 11. So this is how the calculations are, and then we have plotted 21, 11. Now the new pk value is 2. In the next step, we will the new pk value 2. The new pk value is greater than 0. Therefore, the next point to be plotted is x incremented by 1, y incremented by 1. So previously x was 21, 11. Now incremented by 1. So 22, 12. And then I have to find the new decision parameter using this formula. So old pk value plus 2 del y minus 2 del x. So old pk value is 2 plus 2 into del y minus 2 into del x. Yes, so we found a new value called 2, which is the new value. So this new pk value is 2, which is again greater than 0. Therefore, sorry, the value is minus 2 here, minus 2. So 2 plus 16 is 18, 18 minus 20 is minus 2, sorry, minus 2. Since this is minus 2, it falls under case 1. Why? Because it is less than 0. So I am placing minus 2 here. Minus 2 is less than 0. If minus 2 is less than 0, x will be incremented by 1, y will remain the same. That is why x is incremented by 1 to 23 and y remains the same as 12. There is a small correction. This falls under case 1 as it is minus 2. And this falls under case 2 since it is positive. Fine. So, and the new pk value is calculated by using this formula. Not this formula, because this pk is minus 2. Proceeding further, we get the new pk value as 14, which is greater than 0. Therefore, case 2, that's why I'm incrementing both x and y and calculating the new pk value, which results in 10. Since 10 is greater than 0, it falls under case 2. So both x and y are incremented to 25 and 14. I'm finding the new pk value by using this formula. So old pk value plus 2 del y minus 2 del x, which results in 6. Since 6 is greater than 0, it is under case 2. Again, x is incremented by 1, y is incremented by 1. New value of pk that results in 2. Not 2, it is minus 2. No, 6 plus 16, that is 22 minus 20, which is 2. So positive only. Since it is positive, it falls under case 2. So x is incremented by 1, y is incremented by 1. Then again, I'm finding the new pk value by using this formula. So I got minus 2 this time. Since it is minus 2, it is less than 0. Therefore, it falls under case 1. So x is incremented, but y remains the same. And the new pk value is calculated by using this formula. So now the value is 14. Since it is 14 greater than 0, Case 2 has to be applied. X is incremented by 1, Y is incremented by 1, and the new pk value is given by this formula. The new value is 10. 10 is greater than 0. Therefore, the x value is incremented by 1, y value is incremented by 1, and we have reached the endpoint 30, 8. So this is how we will calculate the intermediate points every time. We will move to the points are plotted. The obtained points are plotted to form a line.